Hello third year, welcome to a new week and to sort of new lessons. Some of you guys may recognise these slides from the lockdown before the summer holidays. Some of you may not. It is important that we go back over this again because it's going to make the next lesson make a whole lot more sense. So, today we are going to be looking at chemical names and formula. So our learning intentions are to describe how the formula of a chemical compound can be determined from its name, and describe how the name of a compound can be used to determine the elements present. How will we know if you've been successful? Well, you should be able to use prefixes to write the chemical formula of compounds, and use the endings of words to determine which elements are present in a compound. More on that in just a second. So, what exactly is a chemical formula? Well, it's a way of presenting information about the elements present in a compound. It saves you writing out the whole name. So instead of writing out water, you would simply write H2O. Instead of writing salt, you might just say NaCl. Carbon dioxide becomes CO2. And it tells us a couple of things about these compounds. Today we are focusing on how the names of compounds can help us work out the formula, and what the names of compounds can tell us about the elements present. So what is so important about the names of these chemicals? Well, the name of a substance can actually tell us a lot about it. For example, it can tell us the elements it is made up of, and also, in some cases, the number of each element in the compound. And both of these things are especially helpful when we are trying to put together chemical formula. So how do we name compounds? When we have two or more elements reacting together, they form a compound. Now, compounds are entirely different from the elements they're made up of and have completely different properties. Now, we need to be able to name compounds when we know the elements they come from. So when we name compounds, the metal, which is always found on the left-hand side of your periodic table, always comes before the element from the non-metal side. So if you have a metal reacting with a non-metal, when you are trying to name the new compound formed, the first part of the name is simply the name of the metal. That just stays the same. The second part of the name comes from the non-metal. And if we have an INE ending, for example in chlorine, we would change that to IDE. Now just to refresh your memories, metals are on the left-hand side of this dark staircase here, and non-metals are on the right-hand side. If you don't have that marked in your data booklet, it might be a good idea to pause the video here and do that now. So when we go to name a compound, if it is formed of a metal and a non-metal, the name of the metal will always come first and stays exactly the same. And the non-metal is then the second part of the name, and the ending of the non-metal element will change to IDE. Now let me show you. So, when sodium reacts with chlorine, our metal, sodium, that is the first part of the name. It stays exactly the same. Chlorine is our non-metal, and we change this INE at the end to IDE. So sodium reacts with chlorine to form sodium chloride. Magnesium reacts with bromine to form, well, our metal is magnesium, so that's the first part of the name, and our non-metal is bromine. So just like with chlorine, we take that INE and we change it to IDE, so we have magnesium bromide. And our next example, we have potassium reacting with carbon. Now once again, we have to identify our metal, and it is potassium, so that is the first part of the name, it doesn't change. Now, carbon is a little bit different to chlorine and bromine in that it doesn't have the INE ending. It ends in on. So what we do is we change the ON to IDE and it becomes potassium carbide. Another slightly different one is lithium reacting with phosphorus. Now, lithium would be our metal, it's found in group 1. Phosphorus is our non-metal. Now, instead of changing an INE or an ON to IDE, this time we are taking the ORUS ending and we are changing that to phosphide. So when lithium reacts with phosphorus, it forms lithium phosphide. So let's kind of deal with that backwards then. If we know the names of compounds, can we work out which elements are present? Well, the first one's quite easy. So if we have potassium chloride, we have a metal potassium and we have this IDE ending, which tells us that there's only one other element involved here, and it is chlorine. So we have potassium and chlorine. Now these two down here are slightly different. We have sodium sulfite and copper carbonate. Now, it's very obvious that in both of these, the metals can be pulled out immediately. Sodium and copper. However, instead of an IDE ending, these compounds end in ite and ate. Now, what that tells us is that there's oxygen involved in this compound too. So, sodium sulfite then is made of sodium, sulfur, and oxygen. ITE means oxygen is present. Now in this example we have the ATE ending, and again that tells you that there is oxygen present in the compound. So in this one we have copper, carbon and oxygen. Okay, so let's maybe write that down somewhere. So if the ending is IDE, that means there are two elements in the compound. If the ending is ITE or ATE, that tells us there are two elements plus oxygen. So let's keep that in our brains. So sodium reacts with chlorine and oxygen. Now that means, when we are naming the compound produced, the rules stay the same. So let's look at some more examples. And the first one we have is sodium reacts with chlorine and oxygen, and we are supposed to come up with the name of that compound. Now, as before, the name of our metal comes first. Now, our metal is sodium, and that will form the first part of the name, just like before. So it'll be sodium something. Now, we don't just have chlorine this time, we have chlorine and oxygen. So we have to indicate in the name that oxygen is present. And how we do that is, instead of changing the INE to IDE, we would change it to either ite or ate. In this case, we are going with ate, and our compound is called sodium chlorate. Our second example, magnesium reacts with phosphorus and oxygen. Our metal is magnesium, it's a group 2 metal. It is reacting with phosphorus and oxygen. So we are going to be changing the ending to our non-metal phosphorus, and we have to change it to 8 or 8 because we have oxygen present. It is magnesium phosphate. And last but not least, we have potassium reacting with carbon and oxygen to produce a compound, and that compound is called potassium because that's the metal and the metal comes first, and we are going to change this ending to 8 to tell us that oxygen is present, so it becomes potassium carbonate. Now I have actually another sneaky example for us. Now, if we look back to the top corner, we know that the ending IDE tells us there are only 2 elements involved. And 8 or 8 would be 2 elements and oxygen. So it would be 3 elements. Now, when lithium reacts with hydrogen and oxygen, you might think by following these rules that you get lithium, because that's the name of our metal, and it would be hydrate, because that's exactly what we've done here. We've taken the ending of our non-metal and we've changed it to 8 to indicate that we have oxygen. However, when we have hydrogen and oxygen present together in a compound with a metal, when hydrogen and oxygen are present in a 3-element compound, the ending is slightly different. It's lithium hydroxide. Now, this is the exception to our IDE, ITE, ATE rules. Hydroxide ends in IDE. However, this compound would be made from lithium, hydrogen, and oxygen. So the rule is, if the ending is 8 or 8, there is oxygen present. And if it ends in "ide", there are 2 elements. The exception to this rule is hydroxide. Hydroxide contains hydrogen and oxygen. Okay, so now that we know how to name compounds from the elements they are made of, we are going to move on to discuss formula. Now, in the names of some compounds, we will find prefixes, and they are those are short groups of letters added to the start of words that tell us a little more about the number of atoms involved in the molecule. So if we see the prefix mono, it means 1 atom. Di means 2. Tri means 3. Tetra 4. Penta 5. And hexa means 6. Now, if you do not have this in your jotter or a note of this somewhere, I advise that you pause the video and you make a note of it now. It's worth bearing in mind as we move through this lesson. So how then do we use prefixes to write chemical formula? Now, when we write chemical formula, we will shorten. Now, when we write chemical formula, we are going to shorten the full name for an element down to its symbol from the periodic table. So carbon becomes C, oxygen would become O, hydrogen becomes H, oxygen again is O, and sulfur would be S. So if we look at the names of these compounds, I can spot a prefix here, 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 and here. Now, monoxide means we are going to have one oxygen. Now, it's in a compound with carbon, and now, even though there's not a prefix here, there is only one carbon involved in this molecule, and there's also only one oxygen. Now, we know that because mono or mon means one. If we are shortening the names down to symbols, that means our formula for carbon monoxide will be C for carbon and O for oxygen. And CO will represent carbon monoxide. Let's do the same for dihydrogen monoxide. Now, di tells us that we have two hydrogen atoms involved. And again, mon means one, and we have one oxygen here. So hydrogen, if we remember, is H, so we have two hydrogens. Now we don't write a big 2, it's a small 2, just to the right of our symbol. And oxygen is represented by the letter O. The chemical formula for dihydrogen monoxide then is H2O. Sulfur dioxide then. Now there's no prefix on the sulfur, we're just going to say there's one sulfur atom involved. It's a dioxide, so that means we have two oxygen. So if we consult our periodic table, sulfur is represented by the letter S, and there are two oxygen atoms. It's a capital O and the lower down 2. SO2 is the formula for sulfur dioxide. So that takes us to the end of today's lesson. So hopefully by the end of today, you have either refreshed or learned how to write the chemical formula of compounds using prefixes, and how to use the ending of words to determine which elements are present in a compound. Now, just to remind you, if the compound's name ends in ITE or ATE, that means there are 3 elements involved. One of them is oxygen. If it ends in IDE, there are 2 elements involved. The exception to this rule would be hydroxide, as that is hydrogen plus oxygen. As ever, guys, if you have any questions, please don't hesitate to get in touch with either myself, Mrs. Grimes, or your own class teacher. If there's anything we can do for you guys, we are always more than happy to help. Take care of yourselves and enjoy your week. Bye, guys.